Hi everyone, this is Pranit and welcome to Big Data Factory. I am a data engineer and I work on real production big data systems where Spark job fails at 2 a.m. and where data volumes are in terabytes and where bad pipelines cost real money. I will show you how data engineering actually works in companies, real world architectures, interview ready concepts and mistakes I have personally made so you don't repeat them. If you want to understand big data in a practical, real way, you are in the right place. So let's get into the topic. So, have you ever wondered how YouTube knows what you want to watch next, or how Google Maps predicts traffic, or how Amazon seems to know what you want to buy before you even search for it? All of that is powered by one thing, that is big data. Today, I am going to explain big data in a simple way, what it is, where it comes from, real life examples, its main characteristics, how it's processed, what tools are used, and what we do with it after processing. So, if you are a beginner, don't worry, this video is for you. Coming to the next, what is big data? Big data simply means a very huge amount of data that comes in very fast and in many formats, and normal traditional systems struggle to handle it. So let's make it simple. Like if you think data is like water, then big data is like a whole ocean of water coming in every second. So examples of data, like where does this data comes from? Like it's come from your likes, comments, views, banking transactions, GPS locations, photos, videos, audios, and many more. So big data is not just big in size. If you think it's not, big data is also big in like the speed, variety, and complexity. Now let's get into short history of big data. Big data did not just appear overnight. It evolved gradually as technology and data get grew. In the early days, organizations stored relatively small amounts of structured data such as customer names, product catalogs, and sales records. This data was managed using traditional files or relational database management systems or DBMS. As the internet expanded, websites began generating large amounts of data in the form of clicks, searches, page views, and user activity logs. To handle this growth, data warehouse and more advanced RDBM solutions were developed. However, these systems were expensive and struggled to scale efficiency as data volumes continued to increase. In the early 2000s, the digital revolution accelerated. The rise of social media, smartphones, and widespread internet access led to an explosion of data. Billions of people started generating data every day: photos, videos, messages, location information, and more. Traditional systems could no longer handle this scale of data effectively. To address this challenge, new distributed technologies were introduced that could store and process data across multiple machines instead of relying on a single machine. During this era, frameworks like Apache Spark, introduced around 2014, gained popularity. Spark enabled much faster data processing, supported SQL queries, streaming data, and machine learning workloads, and could run on Hadoop, all while being open source and cost effective. Soon after, cloud computing platforms such as AWS, Microsoft Azure, and Google Cloud Platform emerged, making it easier to store, process, and analyze massive datasets without maintaining physical infrastructure. Platforms like Databricks further simplified data engineering by providing a unified environment for data processing, analytics, and machine learning. Today, big data has become the foundation for advanced analytics, automation, and artificial intelligence. So let's get into some real world big data examples where big data plays a major role in many aspects of our everyday lives, often without us even realizing it. Social media platforms like Instagram, Facebook, etc., analyze what users like, watch, and how long they engage with content in order to show posts and videos that keep them interested. Streaming services such as Netflix and YouTube collect data on viewing habits, including watch time, pauses, rewinds, and search history, to recommend shows and videos tailored to individual preferences. In the banking sector, big data is used to analyze millions of transactions in real time to identify unusual spending patterns and detect potential fraud. In healthcare, hospitals and medical institutions analyze patient records, test results, and medical images to support doctors in making more accurate and timely decisions. Ride sharing applications like Uber and Ola rely on big data to predict demand, set dynamic pricing, and efficiently match drivers with riders. Similarly, Shopping and retail companies use big data to understand customer behavior, manage inventory, and provide personalized offers. These examples show that big data is not just a technical concept but a powerful force that influences everyday experiences all around us. So we get into some characteristics of big data. Big data is often explained using something called the 5 V's: volume, velocity, variety, veracity, and value. Volume means this means how much data, like taking millions or billions of records, huge video files, massive logs. And velocity, this means how fast data is generated and processed. And variety, this means data comes in many forms like text, images, videos, audios, documents, sensor data, and more. And the fourth one is veracity. This means how trustworthy the data is because real world data can be messy, duplicated, incomplete, or incorrect. And the last and the most important one, final one, value. Data is only useful if it helps you get real value, like generates better decisions, better products, better predictions. So, big data isn't just lots of data, it's data that is big, fast, diverse, messy, and needs to become valuable. Now, let's talk about what happens inside big data system. The step one will be collecting or ingesting data. Data comes from websites and apps, sensors and IoT devices, business systems, social media, and external APIs. The data can come in two ways: batch and streaming. Batch means data comes in chunks like daily reports or weekly reports, whereas streaming is like a data comes continuously like live updates. The next part after ingesting or collecting will be the storing part. Because the data is huge, we store it in systems designed for scale, like data lakes, distributed storage systems, or cloud storage. Then, after storing, we go for cleaning the data. This is the very important step before processing the data because bad data can destroy your results. Because the raw data can contain duplicates or null values or any errors. So, we need to remove the duplicates and fix missing values or nulls and correct the errors before pushing into the process. So after that, when we go for processing means turning raw data into something usable. It has a lot of steps in it. Like we sort the data, we filter it, we aggregate it, we join data from multiple sources with multiple data sets. There's a lot happening in the processing the data, which we'll see in the further chapters. And then after processing, we have our data ready, which it will go for analyzing and visualizing. There we create charts, dashboards, and reports, trends, patterns, predictions, and recommendations. So the big data pipeline is basically collect, store, clean, process, analyze, and the output. Now let's discuss the tools. Don't worry, you don't need to memorize them, just understand what they do. So coming to storage tools, we have HDFS, which is distributed storage used for on-premises. And coming to the cloud storage, we have like Amazon S3 as a data lake, Google Cloud Storage. And coming to the processing tools, we have Apache Spark, very popular for big data processing. And we have Hadoop MapReduce, which is older but important historically. And we have Flink, which is good for streaming data. And when it's coming to streaming tools, we have Apache Kafka and cloud streaming services like Kinesis or Pub. And we have data warehouse tools like Hive, Presto, BigQuery, Redshift, Snowflake. And we have machine learning tools like Spark ML tools and Cloud ML tools or Python ML libraries. So think of tools like a toolkit. Some tools store data, some process it, some analyze it. So this is the so what part. Like what do we use big data for after processing? So after processing big data, we use it for better decision making. Like companies look at dashboards and KPIs to make smarter choices. And for personalization, like recommendations, customized ads, and tailored content. Prediction, like predicting sales, customer churn, fraud, equipment failure, demand spikes. And then automation, like automatically detecting issues, triggering alerts, optimizing pricing, and improving systems. And then the innovation, like big data helps businesses create new products, improve user experiences, and compete in the market. So the main goal is turn raw data into insights and insights into action. Let me quickly add something important. Don't think big data means accurate data. Not always. Big data can be messy. That's why cleaning matters. And don't think more data always means better results. Not true. Sometimes smaller good quality data beats huge low quality data. And the third one, Big data is only for big companies, not anymore. Today, even small businesses can use big data tools through cloud services. Big data also comes with challenges like privacy and security, storage costs, data quality problems, bias in data affecting predictions, and managing too many tools. So, big data is powerful, but it needs responsibility. And that's big data, explained in a simple way. What it is, its history, real examples, its characteristics, how it's processed, tools use it, and how it's used after processing. Thank you for watching. If this video helped you, please like, comment, and subscribe. See you in the next one.